Hey there, future professionals. Welcome to Employability Plus, the channel where you'll find everything you need to build the skills that get you hired.
Hello, friends. A new day. I welcome you all again to Employability Plus channel. In today's discussion, we are going to discuss about how to use Solver for transportation model. If you had seen my previous video, we discussed about how to use Solver in assignment model. The rules of the game remain same, but where we are going to apply the concept of, let's say, the function of Solver will be different here. But before we begin, for those who have not seen that video, it's a benefit of doubt. I would like to explain the concept of solver before we jump in and solve the transportation model. So what do you mean by solver? Why do we use it? See, for any business, optimization is critical. As a business owner, either you want to maximize something or you would want to minimize something. When I say maximize something, what do I mean by that? If you want, as a business owner, you would want to maximize your revenue, right, your profit, or let's say your net profit or revenue, or like something which is a kind of a benefit which you want to maximize. Similarly you would want to minimize something like cost, right, something like the duration for, for transporting a product, something which is a limitation. Basically something you want to something which is challenging for you, you want to minimize, right? So in assignment model we had something like we want to minimize the number of employees. At the same time we want to meet the demand, right? So we did that particular exercise where we have ensured that we meet the demand. In the process we had minimize the number of employees. When it comes to transportation model, again it will be similar to that. Changes here is, here we have something called supply location and destination, right? Here objective will be like, we have similarly we will have some criterias, some limitations, like the production place where you have the products getting produced, that might have certain capacity, cannot produce more than the capacity. That will be a criteria limitation. Similarly, place where you are going to send the product, they may have certain demand. If the demand is less, right, if demand is, let's say demand is around 500, you cannot send less than 500 to that location. You can send more than that, you can have stock in that location, but you should not send less than the demand. Like vice versa, it is other way around, like you cannot produce more than. So we have certain criterias, limitations like that. Here the objective for us in a transportation model is to reduce the what? It is reducing the transportation cost or reducing the distance traveled. Both go in hand with each other. The reason being, if you reduce the distance traveled between your supply location, or let's say your the location where you produce to the destination, if you reduce the distance, it will obviously result in reducing the cost. So both are similar. Reducing cost or reducing the distance, both are same, right? So in this case, we are going to, we have a scenario here. The case, let me tell you that the case is, assume that the company produces soft drinks in three different locations like Los Angeles, New York, and Atlanta are the locations identified for producing the product, which is soft drink. And they have their own ab- ability, or let's say the capacity to produce. Right? For Los Angeles, the maximum it can produce is 10,000. For New York, it is going to be 14,000 the maximum, and Atlanta has a maximum limit of 12,000. Now, what it means to us, we cannot send a quantity from here to that place. Now, you might wonder, why I'm taking a case here, like, see, assume that you're working in a supply chain management. Assume that you're working in a retail place where you want to, plan for certain order inventories, or you are working in supply chain management where you are just sending some, inventory from one place to another place. For that, I'm just taking certain examples. This can, relate to that also. The process will be similar, right? You might have sophisticated tools to, do this particular exercise, but at the same time, you can always have a backup, which you can have it in Excel. You can create your own model, right? And you can have it in case if there is something goes wrong, you can always have a plan B, right? So that is an asset for you, learning in Excel, right? Now in this case, we are going to see, like I have explained you the capacity. Now similarly, there is certain demand for each regions. Now these three locations are sending it to different regions. Those regions are four. Assume that you have three locations sending and three locations receiving. Challenge will be limited. But now here is going to be three locations sending, and there is going to be four location which is going to receive it, which is east, midwest, south, and west are the regions which are going to receive, right? Now we have certain places which are identified for sending, for receiving. Now the prices for each locations are given in this box. What do you mean by prices? Now when I send it from Los Angeles to east, it will cost per bottle. It cost me $4. Assume that it's going to cost me 4 bottle per unit. Like when I'm sending it to Los Angeles to east. Similarly, if you're sending it from Atlanta to Midwest, it costs you around 5, right? So so on and so forth. You could see this particular data set. You will identify if it is sending from New York, New York to West, it is going to cost you 4. Like this, there are a lot of information and data given here. Now we are going to find the optimum solution for this particular exercise. What is the minimum cost we can incur? At the same time, we meet the requirements, which is the demand, right? So we are going to solve this through through solver. Before that, let's do the framework. I have created the template already for this. Now what you can do is, like, if you create similar template using this video, what you can do is you can just put equal to sum of, add these informations, because see, this is nothing but the total which will be received in east. Coming from various locations, it will be it will be received in east. So I'm giving the total here. You can copy paste this one, right? And then send is from Los Angeles. You are going to send it to different regions. So what is the total count you are going to send? That we are giving it here. Total count which you are going to send it from Los Angeles to different locations. The total is given here, right? Now, now at this point of time, we don't have any count, but for running a solver, we are giving some dummy variables. I'm just giving some dummy variables. What do I mean by just giving this dummy variables? I'm saying that I'm going to send from Atlanta to south 8 quantity, right? Some dummy variable. And then I'm going to send from New York to east, I'm going to send 3 quantity. Like this, I'm just giving some dummy numbers, right? Now the send quantity is this, right? But the capacity, it is going to be what? It will be like this. The capacity you can send is from Los Angeles to all the locations. The total capacity is 10,000, but I gave only 16. I have sent. For 14,000, I sent only 28. Just a random number I gave, just random number. Some dummy numbers I've entered, but it has the capacity like this, which means that this total should be, in the sense, whatever has been sent, it has to be less than or equal to capacity. So this is okay, but it cannot be less, right? So the capacity has to be less than or equal to this one, the sent. Similarly, in this case, we got the total, right? The total received shouldn't be less than the demand. Okay, in this case, what's the total received? It is 13, right? Similarly, we have 17 as total received. Like this, you have total received. Now, this quantity should not be less than this, because the demand, we need to meet the demand, right? It shouldn't be less than this. So basically, we want greater than or equal to. So now we have created the model. Now let's find the cost, total cost, because that is the objective for us. What is our objective here? We want to reduce the total cost incurred. Right? In this case, we got the prices. I'm saying the cost, in fact, not price, the cost. We have analyzed and we have arrived a cost for each location. Now that cost into number of quantities which have been sent. Now I can do it manually like this. Like let's say 4 into 4 plus, right, 1 into, like this. I can do it like this, right? Wait, why would I do like this? I know, a function called sum. Okay, I don't need to do it manually like this. If I know a function called, sum product, why would I do like this? Let me put sum product. It does the similar thing, which is equal to sum product tab. Select that, comma, and select it like this. Okay, you have selected both the thing, and then what you can do is once you're selected, you'll get the result. Now, well, 238 is not the answer because we have given dummy numbers. Let's give real numbers. In the sense, we cannot give real number. In fact, this is a decision variable the system is going to give us. So we are not going to give anything here. So it's going to be done by the system. So we are going to process this through solver now. So everything is set for solver. Let's understand what we do with solver. Go to solver, set objective. What is our objective here? To get this one as minimum, right? We want to have a minimum number, right? So minimum by changing what? The decision variable. Which cell you can compromise? The decision variable here is basically what is the objective of solver. We are just trying to alter variables in order to meet the requirements. There may be certain constraints. Right now, this is the changing variable. This can be compromised, which means the decision is what we are going to find the decision variables from one location to another location. How many we are going to send, that is the changing variable, because we don't have any control over it and we want to get the best result out of it, right? So we have selected only the total quantity, then add. I'm going to say this send should be less than or equal to capacity. It cannot be sent. You cannot send more than the capacity, right? Similarly, add this whatever received in this region should be should be greater than or equal to the demand. You cannot send, you're not supposed to send, less than the demand. Let's say the demand is 5 units. How can you send less than that? The client will not accept it. If they ask you to, dispatch 5 units, and if you are sending it less than that, they will cancel the order. So there is no point in sending less than the, requirement, right? So we have to give received is greater than the demand, right? So that is add, and then this we can, since it is all, unit wise, this we can say this is an integer. This particular range what we have selected is an cancel. Now we got the thing, we got the objective is minimum cost, changing the number of units which we are going to send, that is the decision variable, and then what are the criteria. Use the simplex and solve. You'll get an optimum solution. When you get this window, it tells you that you got the correct result, you got the optimum result, right? Solver found a solution for this one, so giving okay, you can retain the solution. The solution here is 72,000. It's 72,000. You can have it here, right? Now what is that 72,000? It is the minimum cost you can incur for sending and meeting the requirements. How do you know we met the requirement? Now see this one, 10,000. Is it matching with this? Earlier it was not, because we did give dummy variables earlier. Now it is matching with this. Both are matching, which means that it is right. Similarly, this one also, right? So it is matching. Quantities are matching, right? This is also matching, which means this is exactly matching because we cannot send less than demand. But here though, there is a variance which is 10,000, capacity is 12,000, but we don't need that because we have only 34,000 we need to send for this. Although we have 30, Now, although we have 36 capacity, we are not going to send more than 34, which is the demand. So we have met the what? The demand within the constraints, limitations, whatever we have. In spite of all these things, we have sent the required quantity to the destination. So that is possible because of the solver function. I hope you enjoyed this particular session, folks. If you have still have any doubt in terms of this quality of these videos, right, about this particular channel, please remove all your doubts. You're going to have many more videos going forward, right? And you'll have a lot of informations from my side, and every single day you're going to have what at minimum one learning videos from different you know next. After my Excel, we are going to have Power BI coaching, right? So we are going to have videos from Power BI. So I request you all to subscribe for this channel, right, and support. Thank you so much.